Welcome. In this video, we'll be discussing some fundamental concepts to multiplayer games. We'll first define what multiplayer games are, then cover the various methods for getting information across the network between games running on separate machines. We'll cover the peer-to-peer model, the client-server model, and finally talk about which of these Unreal Engine uses so we can better understand what's going on when we create multiplayer games in Unreal. So let's talk about multiplayer games. Multiplayer games are inherently more complex than single-player games. In a single-player game, the game consists of a single game session running on a single computer. While you could configure a game for split screen, using input from multiple devices on the same machine, this type of game requires no internet and no transfer of information across a network to another instance of the game running on another machine. This is also called local multiplayer. For this reason, when we use the term multiplayer in this course, we'll be talking about true multiplayer, where two or more instances of the game are running on different machines. In a multiplayer game, at least two instances of the game are running, each on a separate machine. Since both players are providing input to change things in the game, controlling a character, for example, the information regarding the change needs to be sent to the other instance of the game. Let's say player 1 moves their character. In order for player 2 to see that movement, information about player 1's character movement must be sent to player 2's machine. But player 2 will also be moving their character, so information about player 2's character movement must be sent back to player 1's machine. So the question is, how do we transfer that information? There are several ways to architect a system for sharing information between game sessions. The first one we'll discuss is peer-to-peer. One of the most simple ways to transfer information is through a peer-to-peer connection. When player 1 moves their character, that movement information is sent directly to player 2's computer. Likewise, when player 2 moves their character, that movement information is sent back to player 1's machine. This is an easy system to implement, and for a simple two-player game, it can work nicely. There are some issues, however. Imagine that we have a third player. Now, whenever player 1 moves their character, they must send that information not only to player 2, but to player 3 as well. Likewise, when player 2 moves their character, they must now send that information to players 1 and 3. And when player 3 moves their character, they must in turn send that information to players 1 and 2. This results in a great deal of data being transmitted across the network, and this doesn't scale well for games with lots of players. Another issue with peer-to-peer is that there is no authoritative version of the game. Each instance of the game is different. Whenever the player moves their character, their local version of the game has now deviated from the versions on the other machines. And it takes a certain amount of time for that information to travel across the network to update the other instances of the game running on the other machines. The question of whose game instance is the correct one has no answer. All instances of the game are different, and none of them is the quote-unquote correct version of the game. Another way to make multiplayer games is to use the client-server model. In the client-server model, a single machine is designated as the server, while all other machines are designated as clients. Every client only ever talks to the server. They'll never send information directly to another client. This means that each client will only need to meet the bandwidth requirements for sending and receiving information to and from the server, rather than to each other machine running the game. So when player 1 moves their character, they send that movement information to the server, which then sends it out to each other client, so player 1's character can then update on those screens. The server is often authoritative, although this is by no means the only way to do it. What this means is that the server runs a version of the game that is deemed to be the correct version. Whenever a player wants to move their character, they actually send a request to the server, which then checks to make sure that that movement is appropriate. Then the server moves the character and distributes that movement update information to all the clients. This distribution of data from the server down to the clients is known as replication. There are different ways to implement the client-server model. One way is to use a listen server. In this case, one of the player's machines acts as the server, so a human is actually playing the game and the machine is rendering graphics to the screen for the server's version of the game. Another way is to use a dedicated server. In this case, a machine is designated to be the server for the game, but no one is actually playing the game on this machine. So there's no need to render the graphics to the screen since there's no one there to actually see them. Dedicated servers allow for the server machine to only handle simulating the authoritative version of the game and replicate data down to the clients. Large-scale multiplayer games like MMOs typically use dedicated servers, along with high-stakes competitive games which host tournaments where money is involved. A listen server does give the hosting player some advantages. Since moving the character doesn't require sending a request to the server, since the hosting player is the server, they don't have the associated lag time that it takes for data to be transmitted. Each client, however, must send requests to the server and wait for the data to be replicated back through the network. For most smaller games, though, this is fine, and with a decent internet connection, the difference is often negligible. As the number of players gets larger and larger, the need for a dedicated server becomes more necessary. So now let's talk about what Unreal Engine uses. Unreal Engine uses an authoritative client-server model. This means that one machine will always act as the server and other machines will connect to it as clients. The server version is the authoritative version and at all times is considered the correct version of the game. When running a single-player game in Unreal Engine, you're still using the client-server model. It just so happens that the client and server are the same machine. We'll learn much more about how this system works throughout this course and how to handle gameplay code in such a way that we maintain the server's control over the proper gameplay mechanics. So in summary, we learned about multiplayer games and exactly what we mean when we refer to a multiplayer game. We discussed various ways to implement the sharing of information between machines, including the peer-to-peer model and the client-server model. We mentioned that the server could be a listen server, where a player is actually playing the game on that machine, or a dedicated server, where the machine is dedicated to simulating the authoritative version of the game and replicating information down to all clients. We mentioned that Unreal Engine uses an authoritative client-server model. Whether that server is acting as a dedicated or a listen server depends on how you configure your project. So we now understand some basic concepts and we're ready to dive deeper into multiplayer in Unreal Engine. I'll see you soon.